Hey guys, this is Miss Farnell. Welcome back to the third and final part of the set series. So if you have not already, please make sure that you have completed part 1 and part 2 of sets before doing this video. If you do not have this little half sheet, please make sure that you do before I get started. You do have to get these notes filled out before you can take the quiz on this section. And then also just make sure you got your writing utensil, as you know at this point. We are just going to jump straight into it. So special number sets. So this is a part of the sets list, but basically what we're talking about is we have these special kind of numbers. So a special collection of different types of numbers in the math world. So these are numbers that fit a very specific set of rules, and we just call it a set. It's just a specific type of number. And these are the symbols that we use. We use these all the time later on. You're going to see them a lot more in some of your future math classes. So this is kind of your introduction to them. So this first one is this fancy R looking one. These are called real numbers. I'm just going to shorten the numbers down to a little hashtag. So this is basically any number that can be placed on a number line, which is a really fancy way of saying it could literally just be like every single type of number. Any number that you can possibly think of. That could be like 0. That could be -6. It could be like 1/2, or pi is a number, or I don't know, 6.4. I don't know. It could be any number that you could possibly think of. Anything that's classified as a number is going to be included there. That's just kind of the big one. After that, we have this Q looking one. These ones are called rational numbers. If you're thinking, why is it labeled as a Q if it's rational numbers? It's because the R was already taken by the real numbers. So that's what we got cooking there. So a rational number, so rational numbers are numbers that can be written as a fraction or a decimal. So basically another way of thinking about this is a fraction or a decimal that doesn't repeat. Or doesn't go on forever. So that has an ending point, basically. So for example, this could be like I said, like it says, any type of fraction. So that could be like 5/2, for example. It could be a decimal. That could be 9.1. It could also be a decimal that I did say that it doesn't go on forever. There is one stipulation for that, and that's a number, like a decimal that goes on forever, but it's the same number over and over again. So for example, if I had 0.5555, and like that just kept going on forever and ever and ever. If you've never seen this before, this little line on top of it would indicate that just continues on forever. In that case, if that's what's happening, if it's the same number, that also works too. So what doesn't work, this is going to be what we call our irrational numbers. Irrational, I can spell. Irrational numbers. So irrational numbers are the opposite of rational numbers. So these are numbers that cannot be written as a fraction, or they are a decimal that does go on forever. So you're going to fill in this blank with a fraction. So one of the classic examples of an irrational number is one that you probably know really well, and that's pi. You guys know pi to be a number that goes on forever and ever and ever, and it's got a very random assortment of numbers, something like that. Another also pretty classic example of a irrational number is a square root of some sort of number where you do not get a whole number back. So the square root of 2 would be 1. But like not the square root of 4. You can take the square root of 4 in your calculator. You just get the number 2. So that's not an irrational number. But most other numbers, when you take the square root of it, are irrational. The next one is Z, which stands for an integer. So an integer is a number that has no decimals. This is what I would call a whole number. So no decimals or a whole number. So this would be like your 0, your -1, the 3, 100, something like that. As long as it doesn't have a 0.5 or a point something something, as long as it doesn't have that decimal, it's an integer. Within the integer family, we have positive integers Positive integers. Positive, so these are basically just positive whole numbers, the positive version of it. In this case, 0 is not included. That's because if you didn't know, 0 is not positive and it's not negative, and that's just because it has no value. 0 is just like, it doesn't have a value. So that's what that means. So positive whole numbers where 0 is not included. The next one, it has a z with a little negative symbol after it. That's negative integers. In this case, these are negative whole numbers where 0 is also not included, just like before. So again, the negative version of the whole numbers. Anything that's negative, -5, -100, things like that. The last one is the most specific, and that's the n one, and these are called natural numbers. In this case, natural numbers, they're called natural numbers because they're the ones that are most common in nature, is how you would say it. These are positive whole numbers starting at 0. So in this case, this seems like the same exact thing as what we have for positive integers, and that's a true statement. These two things are incredibly similar. The only thing that's different between natural numbers and positive integers is that for natural numbers, 0 is included, and for positive integers, 0 is not included. So that's the only difference between those two things. Okay, so the questions you're going to see for this section of the quiz is just basically answering true or false questions about if a number is a part of a set. So in this case, like this question right here, this goes back to part 1 of the sets. This symbol means is or is in. So basically this is asking, is 10 an integer? Would 10 be included in the set of an integer? Well, an integer is a number that has no decimal, and so that's true. 10 doesn't have a decimal, so it is included in that set. Hold on. I need to grab a different pen. Mine's running out of ink. In this case, this next question is asking, is -5 a natural number, the n one? In this case, it needs to be a positive whole number. This is not positive, so it's false. That is not true. The next question is asking, is 6 an irrational number? So aka, is it going to have either basically a pi or a square root on it? In this case, this one is not going to be irrational because it doesn't have the pi and it doesn't have a square root. Next one, we have -2 is a negative integer. In this case, it is a whole number. It is negative, so that is a true statement. After that, it's asking, is 6.32, and then this little, like I said before, this little line on top of it means that it continues on forever and ever and ever. It's asking if that's a real number, and that is true. That's, again, it's just any number that you might possibly think of. This next question is asking, is the set of natural numbers, is that a subset of the positive integers? And remember, that means that everything that is a positive integer, or sorry, that is a natural number, is going to be included in the set of the positive integers. In this case, that is a false statement. That is not true. And the reason why is because not everything that's in the natural numbers is included in the positive integers, because this one includes 0, but this one does not. So that's a false statement. The last one is asking, are all rational numbers in the set of real numbers? And that's a true statement. All of these sets that we talked about are a subset of the real numbers. So that is a true statement. So that's all you have to do for this little quiz right here. It's just true or false. So I'm going to leave you guys to it. If you finish that up, you are done with the set section. If this is your last quiz, awesome, good job. So what you're going to do now is you're going to show the teacher that you made these notes. After that, you're going to take the quiz. If you have any questions, please feel free to ask your teacher. And then you can also try the practice problems that are in the Canvas page along with these. If this is your last video that you have to do for AGS1, congrats, happy for you. Celebrate this moment, you are done. If not, I'll see you in the next video.